Folks, we're done with pages 1 and 2 of the section 1.3 notes, so let's move on to page 3. We are going to talk about measures of spread again. So we are going to introduce two new measures of spread today. They are called variance and standard deviation. Let's first look at variance. The symbol for variance is S sub x squared. So x represents the variable that we're measuring, the quantitative variable we're measuring, and s squared is the term, the symbol we use for variance. It is the average. Notice that average is in quotes. I'll talk about that in just a second. It's the average squared deviation of the observations in a data set from their mean. So let's talk first about what does squared deviation from the mean. What does that mean? Okay, so notice here I have in the definition I'm taking the first observation minus the mean, and then I'm squaring it. And I'm adding that to that, the second observation minus the mean, and squaring that. So that's what means by the squared deviations from the mean. So how do we find an average of something? Well, we add it up and divide by the total number. And here's where the quote average comes in, because we're not dividing by n, we're dividing by n minus 1. So it's not the true average, we're taking the total number of observations and subtracting 1. The reason for that is not important right now. We'll talk about that later in the year. It has to do with degrees of freedom, and it's not important for what we're doing right now. Just know that it is sort of an average, because we're not dividing by the actual number of observations, we're dividing by the number of observations minus 1. Okay, standard deviation. This is a big definition for us in statistics. Standard deviation, which has the symbol of S sub x, you'll notice that the difference between variance is it has lost the squared symbol. It's a statistic that measures the typical distance of the values in a distribution from the mean. So typical distance from the mean is the standard deviation. It's calculated by finding the average of the squared distances and then taking the square root. So basically what we have here is this. I hope that you can see this formula is right here. So we're just taking the square root of the variance. And that's really important for you to remember. The standard deviation is the square root of the variance. Okay, so let's calculate a standard deviation, and this will be the first and only time all year long that I ask you to calculate it by hand. I just want you to appreciate how difficult it is to calculate by hand, and then from there on out we'll use the calculator. So we're going to use the table below to help us calculate the standard deviation of the following distribution. We have 25, 22, 20, 25, 24, 24, 28. Okay, and I've added an extra column in this table to just illustrate an important feature of the definition of variance and why we square the deviations rather than just add the deviations. We'll see that here in a second. Okay, so I'm going to start by adding up all of my observations, and that gives me a sum of 168. Now, I need to calculate the deviation of each observation from the mean, so that means I need to determine what my mean is. So the mean of this data set is 24. Now let's look at the deviations from the mean. Okay, there's all the individual deviations from the mean, and if we add these up, we add all those up, we get a value of 0. So, and the whole reason that I asked us to do this was to show why the deviation from the mean is not very useful to us. It doesn't really give us a measure of spread, because the deviation from the mean, if I add up all the observations, deviations from the mean, it will always equal 0. It has to be. So that's why we square deviations. So in the variance, we have to square these deviations to get any meaningful representation of spread. So let's go ahead and square those deviations. All right, so those are my squared deviations. We're going to add those up. Let's see, 16 and 16 is 32, plus 4 is 36, 37, 38. So the sum of those values right there is 38. So let's take a look back up at our definitions to see what we've actually done so far. So variance is the sum of the squared deviations divided by n minus 1. So we've added up the squared deviations. We just still have to divide by n minus 1 to get our variance. So let's go ahead and do that next. So the variance of this distribution is about 6.333. What does that mean about our standard deviation? Well, our standard deviation is going to be the square root of the variance, and that's about 2.517. So congratulations, folks. You just did your first standard deviation calculation. Tedious to do by hand, not so tedious to use a calculator. So let's go ahead and I want to quickly show you how to do that with a calculator. So I have my TI Inspire here. Going to go ahead and add a listed in spreadsheet, and let's just call this variable X. Then I'm going to enter all my values. There we go. There's all our values. I want to double check because it's very easy to enter data incorrectly. So I'll just double check my values. 25, 22, 20, 25, 24, 24, 28. Okay, we're good. And I've named those values. My variable name is X. So I want to calculate the standard deviation. Now I'm going to go back and add a calculator page. And this can be your friend all year long. I'm going to go to menu, and notice option 6 is statistics, and then we have all sorts of different statistical things we can do. The first one we're going to learn about is stat calculations, and then one variable statistics. So one variable statistics means that we only have one variable we're calculating statistics for. Notice there's also a two variable statistics, and we're not going to use that one yet because we only have one variable. So, number of lists, I only have one list. That list contains the variable X. I grip it and rip it, and bang. Well, look at all that information we get for one variable statistics. I see my mean of 24. The sum of my X values was 168. Those two numbers should look familiar to us. Let's come down here. Hey, look, there's my standard deviation, 2.51661. We wrote it out as 2.517, and that's just a rounded value. This value right here, sigma sub x, I'll explain what that is in a little bit. That is another type of standard deviation. And hey, look at all the bang for the buck we get with this one set of calculations. We also get our 5-number summary: min, Q1, median, Q3, and max. That's awesome. And then again, our squared deviations down here. Really, I can't think of a time we're going to need this squared deviations number, or the sum of the values squared. Really, the one variable statistics gives us the standard deviation, it gives us the mean, it gives us the 5-number summary. Those are the ones we're going to use most often. Okay, let's jump back to the notes here and just talk about some comments about standard deviation. First thing I'd like to mention is the standard deviation, S sub x, measures the spread about the mean. So don't use that statistic, S sub x, with the median. Second thing I'd like to say is standard deviation has to be greater than or equal to 0. And this, I can't think of a better question to ask right now than this. Well, food for thought, folks. When would the standard deviation equal 0? I want you to think about that, and you can expect me to ask you that question again. So I hope you think about that in the meantime. All right, some other comments about standard deviation. Standard deviation has the same units of measurement as the original variable. So if my original variable is in hours, then the standard deviation is in hours. If the original variable is pounds, then the standard deviation is pounds. So just kind of looking back up at our definitions, if the standard deviation has units that are the same as our variable we're measuring, that means the variance has units squared. So that's why variance it's not a very useful statistic to use. Standard deviation is much more useful. For example, If my variable measured is pounds, and that would mean my variance is in pounds squared, which really has no meaning to us. We don't, there's no no useful use of the unit pounds squared. Okay, S sub x is not a resistant measure of spread. In fact, the use of squared deviations from the mean makes it more sensitive to extreme observations than x bar. Remember, a resistant measure of spread, a resistant measure is one that resists the pull of extreme observations, and the standard deviation does not do that. Last but not least, I want to give you a little note here. I mentioned this a minute ago when we looked at the calculator output, and that is the following. Well, that's not very useful, folks. I should not be writing with the highlighter. There we go. S sub x does not equal sigma sub x. They are both standard deviations, so you might be asking yourself, well, what the heck is the one that's the lowercase sigma sub x? So what is the difference between these two standard deviations? Well, S sub x is the standard deviation of a sample, and so far we've been just working with samples of numbers that are from a larger population. Sigma sub x is the standard deviation of a population. And right now I do not want you to be worried about those two differences. All I want you to care about is recognizing that they're two different symbols and they mean something slightly different. We will begin to talk very shortly about the difference between samples and populations, so stay tuned for that. All right, folks, that's enough for this video. We're going to shut it down now and then pick it back up with page 4.